data normally distributed? Question mark. Is it? So far, we almost always assumed that that was indeed the case. In this course, there are many ways of determining that, but in this course, I will show you there's two ways of doing that. Two ways to determine this. One way we've already been doing, I don't know if you noticed it, but it's by graphing data. So that could be a histogram primarily, or a frequency polygon. I'll put that in brackets, right? So, but mainly just graphing is how you could tell right away. Because if you graph, right, and you have a graph like this, it's a little off, that's okay. But if you have a graph like that, if you focus on the peaks and you connect them, right, the midpoints, right, this would be a yes. Looks bell shape, right? Bell shape. That's always what we're after. Would that graph approximate a, and it's never perfect. It's never a perfect bell in real life. But if we notice that it does have that shape, we would say yes, it is, and make reference to it having that bell shape that we're after. If you have data like this, I'm going to exaggerate a little bit. Right, something like that. This would be a no, right? It's not symmetric. It doesn't look like a bell curve because if you connect the peaks, right, it would just not a bell shape. Okay. So if you graph it, you should be able to tell right away, yeah, this one would definitely look like a normal distribution. Second graph, not so much. And it varies, right? It varies, but you can just kind of just look for that. So that's one way that we can determine this. The second way, that's what I'm going to focus on today, is creating what I call a frequency line. And I came up with this because graphing it every time is so time consuming, so tedious. We need to have a faster way of doing that. Okay, so basically what you do is, I will give you the steps here. So I'll kind of cut this off here. Okay. Steps. Find the mean and the standard deviation. If it's not given, you need to find that. Okay. Draw a line like this. Instead of explaining it, I'll just, right, you draw a line like that. You have your mean in the middle. You go 1, 2, 3. No surprises there. 1, 2, 3. So you just keep on adding a standard deviation every time you move right, and you just subtract a standard deviation every time you move left. Slow down a bit. Then you go through sorted list in L1, let's say. It could be in L2, L3, doesn't matter, but it should have been sorted, right? And place each value in the corresponding interval. Okay? Check if data follows the 68, 95, 99.7 rule. That's it. Example, see page 13 in workbook. We're going to go to the workbook because I don't want you to write down like 20 numbers or something for that example. It's just too tedious, too time consuming. Why do only angry people work at a bakery? Because they whip the cream and they beat the eggs. Just thought, my oldest told me that one yesterday. I thought it was pretty funny. So it's worth sharing. Okay, page 13 in your booklet. If you have your booklet, that'd be great, because we're gonna write in this booklet. And if you want to, ripping this out might cause some damage because there's other questions. So I would maybe say don't. So I'm taking this booklet, and if you don't have your booklet, then try to just follow along. You can still do the rest in your notes, right? If you don't have this, you can do everything I'm going to write down here in your notes. Let's start by entering this into L1, and then I'll talk more about what we're doing next, okay? So let's take some time, and I will ask you if this is right. So we'll double check my answer before I continue. So I'm always thinking it takes you about 1 second per entry. That's kind of how much time I give you to enter that. So I'm just going to check. It says that I have 28 entries in my calculator. The first 2, 4, 6, 8, 10, so 28. Yeah, makes sense. So I'm just going to make a note that there are 28 scores in this particular sample. I will change the question here because I made up a frequency line. Okay, create a frequency line using the standard deviation as your interval width. It is always going to be the case. There is no exception on that. So I'm just telling you that And so we're going to scratch B. I'm not going to ask you to make a histogram. It's too time consuming. Okay. So let's go ahead and find our mean, because step one is finding mean and standard deviation. So I'm going to calculate one variable stat. It's just L1. And so the mean is 70. Is that what we're getting? Are you getting that as well? If somebody followed, I hope. 73.11, and that's percent, right? Because it's scores. And then we have our standard deviation, which is 10.58%. Yeah. Okay. So now we have everything we need. So this would be step one. We're going to make our frequency line now. So I'm going to grab my ruler. If I can find it. Oh, here it is. So let's make our frequency line. So it doesn't have to be fancy, nothing fancy, okay? Just make a line, find the middle, right? And then you go 1, 2, 3, 1, 2, 3. All this is a placeholder for us. So it's 73.11. I'm just going to give it a quick. I'm pretty sure. I'm in hours. Trying to find that key. Because there's always a chance that I might have typed in one value wrong, but you know what? The steps do not change. So what we do is we add a standard deviation. So you go plus 10.58. I will not show that every single time. I'll just go from here and tell you what we're doing every step, right? So you grab your calculator, right? And then you add 10.58. And you write that down. It's very important that you're accurate with this. Okay? So you add 10.58 every time, so it's 94.27. One more time. 104.85. And then I will do the same thing going down. I will go a little bit faster, so if you just want to write down today, that's okay, but I still think it's a good practice to do this as we are going through it. So this is 4137. So that's your number frequency line. And then we go and sort our, I will say sort L1, right? So we're going to go stat, sort in ascending order, sort L1, that's done. Then you go back because it's much easier to put them in the right category if they're all arranged already. So then you come over here, I'm going to put this to my left. I would put it to my left, whatever, if you're right-handed. If you're left-handed, it's the other way. So you say 47, where does 47 fit in? It would fit in this category here, would you agree? So you put a mark, 47. 55 is already in here, you put a mark there. 58 is still here. 62, where is 62? It still would be here, right? Because it's still under 62.53. 64 would go in here. 67 still goes there. Another 67. 68. Watch this. There's another 68. When you get to 5, I do this. So 1, 2, 3, 4, 5. The cross is 5, so you know that's 5. There's a 69 here, a 71, another 71, another 71, another 71, a 72, so I keep going above it. Another 72, 74, I'm jumping the next category. So 74, another 74, 76, 81, 81, 82, 84, I'm jumping to the next category. 86, 86, 88, 90, 92. Oh, that's it. 92 is it. So let's do this for ourselves. There's 1 here. You have 3 there. 5 and 5 is 10, plus 2 is 12. There are 6 here, and there are 6 here. If you want to do this, like do a dashed line or something to section it off even more, but you won't need to do that really. It's up to you. Okay. So now check, right? So we made this. So for C, we're going to answer, is this normally distributed, right? Check 68, 95, 99.7 rule. You can't just say, oh yeah, it sort of is. You can't do that. You have to be very specific when I'm not asking you to graph it. So here we go. Plus or minus 1 standard deviation. You check. We have a total of 28 scores, correct? Are you with me on that one? 28 scores, we determined that. How many scores are within 1 standard deviation? If this is my average here, going back 1 and over 1, how many are found within 1 standard deviation? 18, right? I will do this, 12 plus 6, so you see it. So that's 18 over 28. Let's find out what that is as a percentage. What do we want it to be? Remember that first number? 68, right? We want it to be 68%. Let's give it a try. 18 divided by 28. That is 64.29%. So, guys, I'm going to tell you that this is close enough to say 68%. I know you're like, it's not 68, right? So versus 68%, I'll say. So it passes that test. It does pass. You're like, Mr. Dixon, so when will I know that it's not? It will be very obvious. It would be like 80% or 90%. It will be something really, really big above it, or it will be like 40% or something really, really low. So I won't trick you by making it close, right? And you have to decide. Okay, so plus or minus 2 standard deviations. We go back up. This is my mean. So I have to include all 4 here, right? 2 to the left, 2 to the right. So it's 3 plus 11 plus 6. No, sorry, it's 12. Plus 6 plus 6. All over 28. Where did I get that 28 from? At the very beginning, right? There's 28 scores that I'm considering. So this would be 18, 21, 27 over 28. What would that give me? 96%, 96.43% versus what is it supposed to be? We want it 95, right? According to the rule, check, it passes it. It passes it, it's close enough. And then the last one here, plus or minus 3 standard deviations. You might think, Mr. Dirksen, this is kind of pointless. And yes, it is, because it's all of it. So it's 28 over 28, which is 100%, versus 99.7% that passes. So now we conclude, yes, data is normally distributed because it follows 68, 95, 99.7 rule. terrible, right? I used way too much room. I should have probably gone up here, right? But it's because I changed this the way I do it. But you never graphed it. You just made a frequency line. You used your mean and the standard deviation to determine these numbers. You sort your list, and then you place, every number should be in an interval. Every value from the table below above. And then you just go back and make sure, I will do this on my highlighter, with a highlighter, sorry. I will say that this is my middle here, right? You have to understand that that's the middle, and that one standard deviation would be 1 on each side, 2 would be 2 on each side, 3 would be basically all of it. Okay? Homework. Let me just check here real quick, okay? Page 12. Yeah. Only page 12. You're going to do 2 of these. In your workbook. So it's the page before this. And if you want to review quadratics, maybe do this as well. Okay, this one here, 4, right underneath it. If you need a review on quadratics, that's there for you. Okay. Okay. Now we're basically done. Like I'm not tomorrow. I will try my best to weave it all together and see how this is all connected. I'm telling you, from the very beginning, graphing all of our data, line plots, frequency tables, histograms, frequency polygons, normal distribution, z-scores, standard distribution, all of that is connected. I want you to understand that. And so this part right here was just to show how can we show without graphing if data actually follows a normal distribution. This data, if you were to graph it, it would have a bell shape. It would look like this. We know that because we've made sure that it follows this rule. And only now can you actually use, when you use normal CDF, right, to find a probability, you can only use it when data is actually normally distributed. You cannot use it if data doesn't look like a bell shape. It doesn't follow the 68, 95, 99.7 rule. Okay. Yeah, basically page 12. 8 minutes left today. I don't know if you want to give it a go already. At least type them in and find the mean and standard deviation for both. Saves yourself some time. But that is it for today.